The inverse trigonometric functions continued, chapter 7, section 2. Okay, so in the previous video, we were talking about sine, cosine, and tangent, and their inverse cosine, inverse sine, and inverse tangent. Now we're going to go for the other three trigonometric functions, the ones that are a little bit different. We maybe not be as familiar with them. So we're going to deal with inverse secant function, the inverse cosecant function, and the inverse cotangent function. So the inverse secant function. Okay, so we can see what the secant function looks like here. That's that dotted red and solid red line. And remember, the purpose of this is we have to make it a one-to-one function. So we actually make it a discontinuous function. We're going to go from 0 to pi over 2. But you'll see that it goes from, in y values, from 1 to positive infinity, and then from negative infinity to negative 1. Now, when we take that, now that we have it a one-to-one function, then we reflect that over the line y equal to x, and we get the black curves that you see there. So now your domain will be from negative infinity to negative 2, and from 1 to positive infinity, and your range will be from 0 to pi over 2. But remember, there's an asymptote in there, right? So it doesn't include all of that. So let's take a look at this. So y equal to the inverse secant of x means x is equal to secant of y. So we're taking a trigonometric function and we're reversing it to come up with the angle. So easy way of writing this, for the inverse secant function, the domain is the absolute value of x is greater than or equal to 1. That's just an easy way of saying x is either less than or equal to negative 1 or greater than or equal to positive 1. The absolute value of x is greater than or equal to 1. And y is from 0 to pi, but not able to be equal to y equal to pi over 2 because that's an asymptote. If we take the function of the inverse function, the inverse secant of the secant of x gives you x. So if we take the secant of an angle, that gives us a trigonometric ratio. And then if we take the inverse secant of that angle, then we get the original angle back. I should say the inverse function of that trigonometric function, then we get the angle back. So where x is between 0 and pi, and x is not equal to pi over 2. And then if we take the secant of the inverse secant of a trigonometric ratio, we'll get x. So if we take a trigonometric ratio x and take the inverse secant of it, it gives us an angle. Then if we take the secant of the angle, that puts us back to x, our trigonometric ratio, where the absolute value of x is greater than or equal to 1. Now we can see again with the inverse cosecant function, it's doing the same type of thing. Sorry, it's a little hard to see here, but you can see the dotted and solid blue lines. That's our original cosecant function. And then we had to take that over an interval where it was 1 to 1. And then we flip that over the line y equal to x, and that's where we got our red curve. So y equal to the inverse cosecant of x means x is equal to cosecant of y. And please just remember, I just want to put another reminder in this video that the cosecant to the negative 1 of x is not the reciprocal of the cosecant of x. It's the inverse function of the cosecant of x. So basically you're starting with a trigonometric ratio and you're going to get an angle back. Absolute value of x is greater than or equal to 1, and y is between negative pi over 2 and positive pi over 2, but not equal to 0 because that's an asymptote. We take the inverse cosecant of the cosecant of x, we get x, meaning if we take the cosecant of an angle, we get the trigonometric ratio. If we then take the inverse cosecant of that trigonometric ratio, we get the original angle back. And obviously x is between negative pi over 2 and positive pi over 2 and not equal to 0. And then if we take the inverse cosecant of a trigonometric ratio, that gives us an angle. If we take the cosecant of that angle, we then get the original trigonometric function back, x, where the absolute value of x is greater than or equal to 1. And finally, the inverse cotangent function. You can see that we did the same thing as we did with tangent, that we took one of those intervals over which it was 1 to 1, and then we flipped it over the line y equal to x. And notice that we always take the closest thing we can to 0. If we can create our interval balanced over 0, then we do. If we can take if we have to take our inverse, if we have to take our function or our interval where it's not passing over 0, then we take the closest thing to 0. So we take that. So the inverse cotangent of x is equal to y. Means the same thing as x is equal to the cotangent of y, where x is from negative infinity to positive infinity and y is from 0 to pi. Notice that 0 and pi are not included because those are asymptotes. So the inverse cotangent of the cotangent of x gives you x. So if you take the cotangent of an angle, you'll get a trigonometric ratio. If you take the inverse cotangent of that trigonometric ratio, it will give you back the angle where that x is between 0 and pi. And if you take the inverse cotangent of the ratio, that'll give you an angle. If you take the cotangent of that angle, that gives you back that trigonometric ratio x, and that'll be between negative infinity and positive infinity. Whew. Again, very wordy and can be visually very annoying. But the point of this is that we can now calculate these inverse values. So previously we could take the trigonometric function of an angle and find the ratio. Now we can take a ratio and find the angle associated with it, and that's the purpose of this. So let's look at calculating inverse trig functions. And I'm going to give you a special note here. We're now dealing with reciprocal functions, right? We're dealing with cosecant, secant, and cotangent, which are reciprocals of sine, cosine, and tangent, respectively. But we have to be careful about how we treat those when we calculate these functions. So we know that cosecant theta is equal to 1 over sine theta. Okay? But what we have to realize is that doesn't mean that that the inverse cosecant of theta is equal to the inverse sine of theta. That's not the way it works. So basically, what happens is if we're trying to find the inverse cosecant function, since they're reciprocal functions, we're going to take the inverse sine of the reciprocal of the ratio that was given for cosecant, because cosecant theta over 1 is equal to 1 over sine theta. So they're reciprocals. You flip them over. So if we want to use the inverse sine to calculate, we need to take the reciprocal first of our ratio. Then we take the inverse sine. Now, depending on the calculator you have, you may have these functions built into it. If you're using like a TI-83, TI-84, those types of calculators, if you go into the math library, you have inverse cosecant, inverse secant, inverse cotangent. So you can use those directly. If you are using some other calculator, then you can use this method to find the inverse cosecant, take the reciprocal of the ratio, and then use inverse sine. Same with secant. Secant theta is equal to 1 over cosine theta. The inverse secant of x is equal to the inverse cosine of 1 over x. We take the reciprocal first, and then we can take the inverse cosine. And if you don't quite believe me on this, and you have a calculator that has both the inverse functions of sine, cosine, and tangent, and inverse functions of cosecant, secant, and cotangent, try it. Take the inverse secant of some ratio, find your value, then take that ratio and take the reciprocal of it and take the inverse cosine of it and verify to yourself that that actually gives you the same answer. You don't have to believe me. You can try it on your own. And then cotangent theta is equal to 1 over tangent theta. So the inverse cotangent of theta of x is equal to the inverse tangent of 1 over x, that reciprocal. So let's go into this and try some. So back to our standard angles, if we have the inverse cosecant of -2, then that would be pi over 6 or 30 degrees. And again, you can pull that right off of the unit circle. If you have the inverse secant of the square root of 2, then that would be pi over 4 or 45 degrees. And if you have the inverse cotangent of the square root of 3 over 3, that would be pi over 3 or 60 degrees. Again, you can take those right off the unit circle, or you can build your triangles and set up the ratios for cosecant, secant, and cotangent and verify those. If you're using your calculator, such as here, the inverse cosecant of 7.89, then again, make sure that you're in radians or degrees, that you're in the one you want to be in. And you can just plug it in. And if your calculator has the inverse cosecant function, then feel free, plug it in as inverse cosecant of 7.89. If it does not, then plug it in as the inverse sine of 1 over 7.89, right? Flip that ratio, and you'll get 0.13 radians or 7.28 degrees. Inverse secant of 30.7. If you have inverse secant in your calculator, then just plug it in, make sure in your radians, degrees, whichever one you want, and you'll get 1.54 radians or 88.13 degrees. Or if your calculator doesn't do that, then you can take the inverse cosine of 1 over 30.7. And it'll give you the same answer. And then for cotangent, the inverse cotangent of 4.56. If you plug it into your calculator directly, because you have an inverse cotangent, you get 0.22 radians or 12.37 degrees. Or you can plug it in as the inverse tangent of 1 over 4.56, which will also give you 0.22 radians or 12.37 degrees. I hope that wasn't too confusing. Play with it a little bit. If it's not quite making sense, play with the unit circle to work on the standard angles, and play with your calculator a bit to do comparisons to work on your non-standard angles. And remember too, there's nothing wrong with plugging an angle into your calculator and saying, okay, the cosecant of 42 degrees is such and such. Now you have a value. Try to take the inverse cosecant of that and see if you get back to 42 degrees, right? So you can set up your own problems with this. Again, I want to remind you that each of these values that we got for these could occur in two quadrants. Cosecant is the reciprocal of sine, so it follows sine in being positive in the first and second quadrants. Secant is the reciprocal of cosine, so it's positive in the first and fourth quadrants. And cotangent is the reciprocal of tangent, so it's positive in the first and third quadrants. So we can use these as reference angles to put us in those other quadrants also. So we could say the first one, the inverse cosecant of 7.89 could be 7.28 degrees, or it could be 180 minus that, so 172.72 degrees, etc.